Okay, so today we're going to be talking about Rolle's theorem and MVT. The first topic we're going to talk about is Rolle's theorem, which states that if f is continuous and differentiable on the closed interval a to b, if f of a equals f of b, then there's at least one value c such that f prime of c equals 0, or the slope of the tangent. And we can see this visually on a graph on our interval a to b. We can see that f of a equals f of b. Therefore, by Rolle's theorem, there exists some value c such that the slope of the tangent equals 0. Now for an example problem, f of x equals x squared minus 5x plus 4 on the interval 1 to 4. So the first thing you want to do is test if it's continuous and differentiable. And we know that it's continuous and differentiable on this interval because it's a polynomial. And then the next thing you want to do is test the endpoints. So f of 1 equals 1 squared minus 5 times 1 plus 4, which equals 0. And f of 4 equals 4 squared minus 5 times 4 plus 4, which also equals 0. Since f of 1 equals f of 4, therefore, Rolle's theorem applies. The next thing we can do is solve for our derivative. So by power rule, f prime of x equals 2x minus 5. And then we can set our derivative, f prime, equal to 0. And x will equal 2.5. Which, this means that at 2.5, the slope at c will have a slope of 0. So according to our graph, at 2.5, f prime of c equals 0. And the next topic will be MVT. So MVT states that, again, if f is continuous slash differentiable on the interval a to b, then there exists a value c such that f prime of c equals f of b minus f of a over b minus a. What this is essentially saying is that the calculus slope, or the slope of the tangent, is equal to the algebra slope, or slope of the secant. Okay, and we can see this on a graph on our interval a to b, on our function, which is this, the slope of the secant, at some value c, the slope of the tangent by this line equals the slope of the secant line. Okay, now for an example problem. F of x equals x cubed on the interval 0 to 1. So again, as in the last problem, it's continuous and differentiable. Therefore, MVT applies. So then the next thing you want to do is solve for the endpoints. F of 0 equals 0 and f of 1 equals 1. And then we can solve for the slope, or m, of the secant. So f of 1 minus f of 0 divided by 1 minus 0 equals 1. And then the next thing we want to do is solve for our derivative, f prime of x by power rule equals 3x squared. And we can then set our derivative equal to the slope. So 3x squared equals 1. Therefore, x ends up being positive negative root 1 over 3. So this is essentially saying that at this point x or c, the slope of the tangent equals the slope of the secant. So now for one last example problem, f of x equals root 1 minus x squared on the closed interval -1 to 1. And you want to, just because it's not continuous outside this interval, you just want to be concerned with inside this interval. So inside this interval, this function is continuous and differentiable. And same as the last problem, solve for the endpoints. F of -1 equals 0, and f of 1 equals 0 as well. So solve for the slope, solve for this, f of 1 minus f of -1 over 1 minus -1 equals 0. And then we can solve for f prime of x, which equals, by chain rule, 1/2 times x minus 1 minus x squared to the -1/2 times -2x, which ends up being negative x over root 1 minus x squared. And we can set this equal to 0. And then we solve for x, which ends up equaling 0. So at 0, the slope of the tangent will equal the slope of the secant.